Hello everyone. In today's class, we are going to learn about chemical equations. In the last class, we learned about few chemical reactions. The first one we saw was magnesium ribbon burning in the presence of oxygen. So we will write an equation, word equation. We'll put the statement into an word equation. Magnesium plus oxygen gives magnesium oxide. Now, is there any other simplest way to represent this chemical equation? See, every element has a particular symbol. Now, we'll convert this particular equation, word equation, into the chemical formulae. Magnesium is Mg. Oxygen is O2. Magnesium oxide, MgO. Now, this is the simplest way of representing a chemical equation. Now, I'll give you one more example. Zinc plus sulfuric acid gives zinc sulfate plus hydrogen. The symbol for zinc is Zn. Sulfuric acid is H2SO4. Zinc sulfate is ZnSO4 plus H2. So you can use chemical formulae instead of words. That is the simplest way or the shorter way for representing chemical equation. Now, how do you write the formula? Now, for writing the formula, you need this tabular column. See, each ion has a representation. See, these are the names and symbols of some ions which will be helpful to write the chemical formula. Okay, so now here you see sodium is Na plus, potassium is K plus, silver is Ag plus, and copper can take two different states or two different valency. Copper is 1 here, and you can also have copper 2, Cu2 plus. So copper can exhibit variable valency. So 1 and 2, the different types of valencies for copper is 1 or 2. Okay, so these are all mono-positive ion or the metals where the valency is 1. Okay, the charge is 1, valency is 1. Valency is the combining capacity of a substance, of an element. Now, coming to the next category, magnesium, calcium, zinc, iron 2, copper 2. Now, all these elements has valency 2. Aluminium and iron has valency 3. Now, see, copper can have two valencies. Copper it takes two valencies, 1 and 2. Similarly, iron takes two valencies, plus 2 and plus 3. 2 and 3. Okay. And here we have some more non-metallic element, hydrogen. Hydrogen has plus 1 or hydride. Hydride is minus 1. Chloride, bromide, iodide, fluoride, all halides has valency 1 with the charge minus. Oxide is O2 minus. Sulfide is OS2 minus. Nitride is N3 minus. Now, there are some polyatomic ions. Ammonium is NH4 plus. Whereas ammonia is a neutral molecule which has the formula NH3. Okay, and ammonia is a neutral molecule, whereas ammonium is a positively charged ion. Okay, it is made up of N and 4 hydrogen, NH4 plus. Therefore, it is called as polyatomic ion. Poly means many. Ions made up of many atoms. That is polyatomic ion. Hydroxide ion is OH minus. Nitrate is NO3 minus. Hydrogen carbonate is also called as bicarbonate. Bicarbonate is HCO3 minus. Carbonate is CO3 2 minus, sulfite is SO3 2 minus, sulfate is SO4 2 minus, and phosphate is PO4 3 minus. This tabular column is very important. Make sure you are familiar with the symbols and the charges. This will be helpful to write the formula. Okay. Now we'll take an equation. Fe plus H2O gives Fe3O4 plus H2. So this is the chemical formula for iron, water. This is H2 is water. Fe3O4 is iron oxide, iron 3 oxide, and hydrogen. Okay, so this is a mixed oxide. Fe3O4 is a mixture of FeO and Fe2O3. It's called mixed oxide, which is Fe3O4. Now we have written the chemical formula for 3 equations. Now we are going to learn how to balance the chemical equation. See, whenever you are writing a chemical equation, you have to give the balanced equation. Okay, so we'll move on to the first equation. Magnesium plus oxygen gives magnesium oxide. Now we have written the formula, but you have to balance it. See the number of atoms on both reactant side and product side. Reactants are the one on the left hand side and products are the one on the right hand side. Now see, oxygen, there are 2 oxygen on the reactant side, but on the product side you have only 1 oxygen. So to balance oxygen, you put the number before Mg. You shouldn't put MgO2. That makes the formula wrong. See, whatever number you're writing, it should be before the symbol. Okay? So, it is MgO. Now, we have balanced oxygen. Now, magnesium is 2. 2 magnesium on the product side. But on the reactant side, we have only 1. So, make this as 2. Now, you check. Magnesium is 2 on both the sides. Oxygen is 2 on both the sides. So, this reaction is balanced. Okay, you got it? Now we'll move on to the next equation. Zinc plus H2SO4 gives ZnSO4, zinc sulfate plus hydrogen. Now we'll take zinc. Zinc is 1 on both the sides. Hydrogen, H2 on both the sides. And sulfate, SO4 on both the sides. So the equation is already balanced. Now we'll take Fe plus H2O gives Fe3O4 plus H2. Okay, now we have to balance this equation. This is not balanced because on the product side we have Fe3. Okay, so we'll take the element other than hydrogen and oxygen. See, whenever you are balancing the chemical equation, hydrogen and oxygen should be balanced towards the end. So we'll first finish off with iron, Fe. So here we have 3. So put 3 here. 3 Fe plus H2O gives Fe3O4 plus H2. Now we'll balance oxygen. Oxygen is 4 times on the product side, but on the reactant side we have only 1. So I'm going to balance oxygen. To balance oxygen, I have put 4. Now hydrogen has become 8. 4 into 2, 8. Now here we have only 2. So balance hydrogen. Now after balancing, you check the number of atoms on both the sides. Iron 3 on both the sides. Hydrogen 8 on both the sides. Oxygen 4 on both the sides. So the equation is balanced. Okay. Now we'll take few more examples. There are word equations given here. You have to convert the word equation into chemical formulae and then you have to balance it. We'll take the first equation. Hydrogen plus chlorine gives hydrogen chloride. Now you convert this into formulae. Hydrogen is H2. Chlorine is Cl2. Gives hydrogen chloride. Hydrogen chloride. Hydrogen is H. Chloride. Chloride is Cl minus. Hydrogen is +1. Now you have to use the tabular column which we learned, the symbols and the charges, which will be helpful to write the formula. Hydrogen chloride is HCl. Now see the number of atoms on the reactant side. You have 2 hydrogen and 2 chlorine. So on the product side, if you put 2 here, both hydrogen and chlorine will be balanced. So the equation is balanced. We'll move on to the next one, barium chloride. Now, how do you write the formula for barium chloride? Barium has the symbol Ba with the charge or with the valency 2. Chloride is Cl minus 1. Okay, barium is the metal. Metals will always have positive charge, and barium has the valency 2, or it has the charge plus 2. Now, neglect the charge, take only the valency and crisscross. Crisscross. The formula for barium chloride will be Ba and Cl2. BaCl2. Okay, so write down the formula. Barium chloride is BaCl2. And aluminium sulfate. How do you write the formula for aluminium sulfate? Aluminium has the charge 3 plus. Okay, aluminium is a metal. Valency is 3, has a charge plus. Sulfate is SO4, 2 minus. Okay, neglect the charge. Crisscross the valency. Al2, SO4 thrice. Okay, SO4 thrice. Sulfate is a polyatomic ion. So this is how you write the formula. So barium chloride is BaCl2. Aluminium sulfate is Al2, SO4 thrice. Gives barium sulfate. Now, how do you write the formula for barium sulfate? You know the charge for barium. Barium is 2 plus. Sulfate is 2 minus. SO4, 2 minus. Now, if you have the same number, you can omit the number. Okay? You can omit the number. The formula will be BaSO4. BaSO4. Now, aluminium chloride. How do you write aluminium chloride? Formula for aluminium chloride. Aluminium is 3 plus. Chloride is minus 1. Okay? Chloride is minus 1. Now you crisscross. The numbers alone. AlCl3. Aluminium chloride. AlCl3. Now you have to balance. Now see the number of atoms both on the reactant side and product side. If the numbers are equal. If it is not equal, you have to balance it. So now you have to balance the equation. Barium is 1 on both the sides. It's balanced. Aluminium is 2. So I'm going to put 2 here. Okay. If I balance aluminium, chloride becomes 6. 2 into 3, 6. So we put 3 here. Now when you put 3 here, barium becomes 3. So put 3 here. Barium. Barium is 3 on both the sides. Aluminium is 2 on both the sides. Chlorine is 6 on both the sides. And sulfate is 3 here. Also 3 here. So the equation is balanced. Always after balancing, you have to check again whether all the atoms are balanced. Okay, we'll move on to the third one. Sodium plus water. Sodium is Na. Water is H2O. Sodium plus water gives sodium hydroxide, NaOH. Sodium hydroxide is NaOH plus hydrogen. Hydrogen is H2. Okay, now you have to balance. See, Na is balanced. But hydrogen, you have only 2 here. But we have 1 plus 2, 3. Okay, so we have to balance hydrogen. To balance hydrogen, I'm going to put 2 here. Now, hydrogen is 2 plus 2, 4. So we'll make the hydrogen balanced here. Put 2 here. So hydrogen becomes 4. Oxygen is 2. Oxygen is balanced. Now sodium is 2. Put 2 here. Okay, now everything is balanced. Hydrogen is 4. 2 plus 2, 4. Okay, so this is how you have to write the formula and the symbols. You have to work out more examples. If there is any doubt, you can give your doubt in the comment section. Now write a balanced equation with state symbols for the following reactions. Now what is state symbols? State of that substance, whether it is solid or liquid, or it is solution, or the salt is dissolved in water, we will learn that. If it is a gaseous substance, you put G. For solid substance, we put solid, S. If it is a liquid, we put L. Now, if any salt is dissolved in water to form a solution, then you write it as aqueous. Say for example, NaCl aqueous. That means NaCl is dissolved in water. Aqueous means the solvent is water. Okay. Barium sulfate aqueous means barium sulfate is dissolved in water. Okay. Now we'll convert this statement into equation, chemical formula, and then you have to balance it. Say solutions of barium chloride and sodium sulfate in water reacts to give insoluble barium sulfate and solution of sodium chloride. So barium chloride and sodium sulfate solutions are reacting. So first one is barium chloride, BaCl2. Now, how do you write sodium sulfate? Sodium is Na with the charge 1. Valency 1, charge plus. Sulfate is SO4 2 minus. Crisscross. Crisscross the numbers. It is Na2SO4. Na2SO4. So the formula for sodium sulfate is Na2SO4. Now these two are reacting. Now these are solutions made in water. So the state of the symbol will be aqueous. Okay, since they have asked the state of symbols, you have to mention it. Now these two are reacting to give barium sulfate. We already saw the formula for barium sulfate. Now this is insoluble. Insoluble means it is solid. Insoluble barium sulfate means it is a precipitate. So precipitates are given a downward arrow mark. And solution of sodium chloride, NaCl aqueous. These are the states of the symbols. Okay. Now we have to balance. Barium is 1 on both the sides. Cl is 2. So to balance Cl, I'm going to put 2 here. Na is 2 on both the sides and sulfate is 1 on both the sides. The equation is balanced. Okay, is that clear? We'll move on to the next one. Sodium hydroxide in water. Sodium hydroxide is NaOH. In water means it is aqueous solution. Reacts with hydrochloric acid solution, HCl, aqueous, to form sodium chloride solution. Sodium chloride is NaCl and water. Water is H2O. H2O is liquid. So Na is 1 on both the sides. OH, okay, hydrogen. See, hydrogen, there are 2 hydrogen and here we have H2. Balanced. Hydrogen is balanced. Cl is balanced. Oxygen is 1. So the equation is already balanced.